So here's an example for the time frequency resolution for the second stage of the layer 3 coder. So the first stage has a 32 subband QMF filter, but we are going to take a deeper look into PQMF filters later on. So for simplicity, we will take only an MDCT, and the MDCT is used on the second stage of the layer 3. And for example, we can visualize a 32 subband filter bank with some Python code. So I already go deeper and I explain this Python code in different lectures. So for example, you can take a look at the multi-rate signal processing class where I go through this code. I also talk about this code on when we talk about filter banks in audio coding classes and tutorials, and also on advanced digital signal processing. I think you can also find something about the MDCT there. But just a general overview, we'll use PyAudio to deal with audio, and also we use OpenCV for the visualization, some IPython widgets for a GUI, and some general if we need to plot something. And for signal processing, we use NumPy, PyPlot, and a SciPy signal. So here we have our signal processing parameters, and we're defining the number of subbands equals to 32. But have in mind that the way this implementation is done, it cannot handle well these 32 subbands. It happens some kind of overflow in the data stream, and so you will not be able to hear any audio, but you can still see the subbands. So here we use our MDCT implementation using the delay matrix, the delay inverse matrix, the F matrix, the DCT4 transform. So here, if we run here our code, it should open a new. And here you can see it's very narrow spectrogram, and you can see we cannot hear anything, but we can visualize, and we see that it's quite fast because we downsample only by 32. And you can do some modifications in the code, so you can hear, you can listen to a specific subband by setting the other subbands to 0, and then you will hear something that more than just a tone, because the subbands are wider than for the HeAAC, for example. Now, if we set the number of subbands to 576, that is after the second stage, after the PQMF filter bank and then the MDCT filter bank, we'll have this number of subbands. So let's change this to 576, then we can run our cells. And then if we start, now we see is much quieter and not as fast, but you can also hear. So if I turn off my microphone here and just leave it to the MDCT. Let me try that. Okay, so now I have just going through the MDCT, and I'll go back to my microphone. So we see that it becomes more similar to a HeAAC filter bank, and we see a broader spectrogram, but it runs a bit slower because we have an increased downsampling rate of 576. So the second layer does it by replacing every 12 or 18 time samples in each of the 32 subbands by 12 or 18 finer subbands. Then if we would listen to a subband, it would sound more like a tone because the subbands now are more narrow. Here we see a header of bitstream, for example, used in the MPEG layers 1, 2, and 3. And it's very important when we're streaming something over digital radio or internet, and we need some information so that the decoder can play back what is being streamed. And for example, here we have a sync word, and the sync word allows decoding this starting in the middle of a file, which is very important for broadcast applications. And we also have other information that are used by the decoder to decode the audio and to be able to play back the bit streams that it receives.